Good morning. Today we'll discuss about numerical distance protection of transmission line, and in particular the Mann and Morrison method of determining the impedance required for distance protection of transmission line. In the last week, in the last video lectures, we have seen how to implement numerical relays for protection of transformers. We have seen overcurrent relay, and in the last lecture itself, we have seen how to implement a differential relay for the protection of transformers. We have seen the block diagram, we have seen the dual slope characteristics which are widely employed now, and also we have seen the steps which you are supposed to take while you are designing a numerical differential relay. And we have also seen a practical model of differential protection relay based on manufactured by Siemens. And we have developed a flow chart of what a programmer must do before he designs a numerical differential relay. And in this lecture, we will start developing the numerical distance relay for the protection of transmission line. So I hope that by the end of this lecture, you will be able to describe how the numerical distance protection is implemented for transmission line, and also how to determine the impedance of the transmission line using Mann and Morrison method. So I'll start with what actually is a distance protection and what is the principle involved in distance protection and why distance protection are widely used for transmission line protection. And I'll also start with the numerical distance protection, what actually we are supposed to concentrate and how it is to be implemented. And then we will move on to the Mann and Morrison method, which is generally employed to determine the impedance. And if possible, if we do time permits, and I'll solve a problem on Mann and Morrison method also. Now, coming to the start, that is the introduction to distance protection. Normally for a power system, let us suppose this is the generator, this is the load, this is transformer 1, this is transformer 2, and this is the transmission line. Normally the different types of protection which we offer here are, one is overcurrent protection. Generally we do employ overcurrent relays and voltage relays, under voltage or over voltage relays. And sometimes we do go with frequency relays and especially differential relay. We have seen differential relay also. And the major thing which is widely employed for the protection of transmission lines is distance protection. We have seen all these things in the previous classes. Now we will see how distance protection is implemented. As the name itself indicates, it actually depends upon the distance of the feeding point to the fault. Let us suppose if I keep a relay here, distance relay, so where the fault has occurred. So the impedance between these two, it will be required, or it will be the influencing factor for the implementation of distance protection. So now the question arises, how it basically works, distance protection. Distance protection, it always measures the impedance of the line and then it compares it with the predefined value, and if it is greater or less than that value, then automatically it will give a trip signal. So the time of operation of this particular distance relay, it depends upon the impedance which it will be measuring over the time. So normally Z, which you know it as V by I. So every time you will be measuring V, every time you will be measuring I. So the ratio of these two, the impedance, based upon the value of impedance, the time of operation of such protection will be there. Okay, and this impedance, normally it will be in terms of length, it will be by unit length. So as the length varies, the impedance also will be varying. So the impedance between the relay and the fault depends upon the electrical distance between them. And there are different types of impedance relays which are widely used. This is a broad protection scheme. So if Z is V by I, if it is not beyond your limits. If it is beyond your limits, then your relay will recover. There are so many types of impedance relays. We call them as impedance relay, reactance relay. Sorry, this is mode relay and the mode relay. So these are the relays which are generally employed. Normally you do have different types of transmission lines, the short, medium and long transmission lines. So for each of these transmission lines, you may ignore some components. If you take a short transmission line, you will consider only R and L. You will ignore the capacitance and conductance. For a medium transmission line, you will consider R, L and C. Whereas for a long transmission line, you will consider all the 4 parameters. So based upon the parameters which you will be considering for modeling, similarly, the protection schemes also, they are based upon those of your assumptions. So that's why you will be having whether impedance relay or reactance relay or more relay. Now, how it basically works. So we have seen the introduction part. So how basically it works. Normally your overcurrent relay or your overcurrent relay, if you take your overcurrent relay, it will operate when the current is greater than your pickup value. Or if you take a voltage relay, it will operate when your voltage is greater than your pickup value. You take dV by dt. It operates when your dV by dt is greater than your pickup value. So normally all these things, they depend upon either voltage or current. But whereas a distance relay, it operates on ratio of these two quantities, which means that you are supposed to measure V, you are supposed to measure I, and V by I, the impedance. If it is greater than your pickup value, then automatically your relay will be operating. So that's why impedance relays are called as double actuating quantities, because they do require two inputs. One is a voltage input, the other one is a current input. So there will be two coils present. Two coils will be there. One coil will be energized by the voltage, the other coil will be energized by the current. So that's why there is a double actuating quantity relay with one of their coil energized by the voltage, other coil is energized by the current. So two coils will be there in the distance protection. The current element produces a positive pickup torque, so it will develop a T plus, whereas this will develop a T minus or a reset torque. Now the relay will operate only when the ratio of voltage and current falls below a set value. So normally Z is there. If it is, then only your relay is going to operate. Okay. So now the question is, so at any given point of time, normally if you take a transmission line, at any given point of time, let us suppose the voltage and also this is the current, and this will give the current, this will give the voltage. So the current and voltage will be measured with the help of, this is a CT, this is a PT. Now this is my point. Okay. So if V is there, then automatically if I measure here, this is V measured. It depends upon the distance between the PT and also fault, because there will be a drop here. Okay. If the fault is nearer, measured voltage will be less. And if the fault is farther, the measured voltage may be higher. Okay. So assuming constant fault impedance, each value of the ratio of voltage and the current measured from the relay location compared to the distance between the relaying point and fault points along the line. So this V I generally remains a constant if you consider a short transmission line. Normally I will be constant, only V will be varying based upon the distance. So normally, since V is depending on the distance from your point of measurement to the point where you relay is, so that's why it is generally considered as a distance relay. So it will be varying based upon your distance. Okay, this is the meaning of this one. Now let us suppose there is a fault which is happening here. If the fault is nearer, then the measured voltage will be a little bit less. If the fault is farther, then the measured voltage will be higher. So the measured voltage always depends upon the distance. That is why it is called as a distance relay. Now if you carefully see, there is a fault. Here I do have a relay. Okay. Normally there is a I, and here I am measuring V, and these are being recorded here. Okay. Now normally, sorry. Yeah, I'll explain it again. This is a relay. Here you will be measuring the current, and here you will be measuring the voltage. Now, here let us suppose there is a fault happening here. Okay, if the fault is happening, then automatically what happens is the current will be flowing in this way, which means that you are measuring the current. But the voltage, since it is being shorted, here what will happen, you will be getting a zero value. Right. If the fault is nearer, then the voltage which you are measuring here, it will be normally, to be more precise, let us suppose this is V1 and V2. This is what your voltage drops is here. Now let us suppose if the fault is happening here. This is a fault. So since the current will be flowing in this way, your voltage will be a little bit less. If the fault is farther, then the voltage will be a little bit higher. The voltage which you are measuring here. So the ratio of V by I is going to change. If there is a fault, then automatically the V value will be collapsing. Okay. So your Z value will be collapsing. Okay. So how much it will be, if it is very nearer, then automatically then the V value will be very low, then the Z value will be very low, and since it is less than your Z set value, then automatically your relay will be operating. Okay. So the major features of this one is it all depends upon the distance. That's why try to remember, since if it is very farther, then it is difficult for this relay to identify whether there is a fault or not. Sometimes they will be under reach or sometimes they will be over reach also. So that's why what we do is nothing but we generally employ a 3-zone protection. That I'll come in the next class. Okay, 3-zone protection of. I think we have discussed this one in unit number 3. For transmission and also we do employ 3-zone protection to overcome this underreach and overreach problem. Okay. So apart from this, let's get back to the main points. Distance zone is a non-unit protection, which means that the protection zone is not exact. The distance protection is a very high-speed protection and is very simple to apply. You are not doing anything. Yes, you are measuring the voltage and current. You are taking the ratio of that, and that you are employing here. Normally, it is used as a primary protection, and sometimes it is used as a backup protection also. So generally, we do employ it for the elements which do spread over a longer distance. So in power systems, the longer distance elements are transmission lines. So that's why it is widely used for the protection of transmission lines. And normally for both phase fault and also ground fault protection, distance relays are used. Okay. So now this is in general about your distance protection. Now we will see how specifically this can be applied to your transmission.